Here's integrated 3. It's problem 8-34. It's asking about the degree of some polynomials, and it's going to show some graphs. Okay, so I want to be clear about how you can tell the degree of a polynomial by just looking at its graph. So we all know what a parabola looks like. This is a quadratic. A quadratic, like if this was our parent function, it would just be y equals x squared. And that's degree 2 because of the exponent. But we know that, so the degree on this would be 2. The degree on the cubic would be 3. So this is degree 2. This would be 3. This would be, the degree would be 4. And this, the degree would be 5. And you can tell the degree from the equation by looking at it in standard form, standard form, where it's like y equals ax squared plus bx plus c. So you look at the highest degree, or the highest exponent, the term that has the highest exponent. Okay, so, but we also know that we can have a quadratic in factored form. And the factored form would give us some intercepts. Like this would give me an intercept at -1 and an intercept at 2. So it can have 2 intercepts. It couldn't have more than 2 intercepts because, I mean, look at it. If I drew like an axis, you could have 2 intercepts but not more. So this is a degree 2. This is a cubic. And you can write it in factored form. It'd have 3 intercepts, one at 0, one at 2, and one at -1. And it would, you could tell it's degree 3, especially if you write it in the standard form, because the exponent here has a 3, so that's degree 3. This quartic it would have the highest exponent on it would be 4. So it could have up to 4 x-intercepts. If I made like the x-axis right here, it could have 4 intercepts. And a quintic could have up to 5 x-intercepts, because maybe it would cross the x-axis 1, 2, 3, 4, 5 times. And this would look something like y equals x to the 5th plus blah, 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 blah. Okay, and I have some, I actually put some on Desmos for those who missed class. Oops, it wants me to log in again. Okay, so here are some examples of different degrees of polynomial. Here's just this is just a 2nd degree polynomial. It's a quadratic. This is a 3rd degree polynomial, and we call it any 3rd degree polynomial, we're going to call it a cubic. And you can see it has like the different intercepts. This is actually that same cubic, but I just wrote it in standard form. Right? You can just multiply it out. See? This thing, so you're just getting used to, like we spent some time getting used to what these all look like. This green one, this one is y equals x to the 4th, which doesn't look much like the picture I just showed you. I showed you a picture that looked more like that. But what happens is if you raise something to the 4th power, it just kind of like, or any even power, it just kind of flattens it along here, and it makes it almost look like a quadratic. But if you get a quartic, see, you could still, if you multiplied that out, you'd have something raised to the 4th power, because you'd square that out, and you'd square that out, and anyway, this would end up with the x to the 4th in it. And this has intercepts at -3 and at -1. So that's a quartic. It has degree 4. This one's another example of a quartic. I wanted to give you a curvier one. So notice all 3 of these are quartics right here. So they can look all different ways. So that's why your book is asking you, your book's asking you a specific question. So here's your book. It says, what is the degree for each polynomial function below? And for parts C and D, state the minimum degree. So this one I can just look at, it's in standard form, so I just look at the exponent on the x squared. The highest exponent of all the terms is 2, so that's degree 2. This one actually they didn't put it in order, but this would be 5 because this x has a power of 5. This is a quintic right here. This one down here it might be even higher than a cubic because, like we were saying, sometimes stuff flattens out, but it has to at least be a cubic. So it's the minimum degree. So this has to, because it has like 3 intercepts, it has to at least be a cubic. This one, just because of its curviness, this has to at least be a quartic, if not higher. I mean, these could actually be raised, instead of squared, these could be raised to some other positive or other even power. But this thing is called a quartic, and they're usually shaped kind of W-ish. And it's degree 4. And another thing that might have been missed if you were absent was that things that, I'm going to go back to this. Things that have an even degree, like this one and this one, see the end behavior, the little arrows, they point in the same direction. If you have an odd degree, you're going to have one arrow pointing up and the other one pointing down. So those are just a couple things that you may have missed.